Hi all, this is Harini. Welcome back to our YouTube channel Code with Harini. Today we are going to solve July day 18th LeetCode challenge, minimum difference in sums after removal of elements. So they will we have to find minimum difference between sums in the given array. We have to partition the array into two parts and we have to find out the minimum difference between the sums. So what they are telling here, they are giving us a zero index num consisting of 3n elements. So we are allowed to remove any subsequences of elements, okay, of exactly n size from nums. The remaining 2n elements will be divided into two equal parts, okay. So what they are telling, they will be giving us three times of n's. For example, if it is n equals to 1, we'll be getting 3 elements, n equals to 2, we'll be getting 6 elements, n equals to 3, we'll be getting 9 elements. So what we have to do, we have to remove if the n elements in the given 3n elements. So the first, whatever comes first will be the first part, the last n elements will be the second part. So that's what the first n belongings to the first part, sum first, sum minus. So the difference of the sum in the two parts, sum first minus sum second. For example, sum first is 3, sum second is 2, the difference is 1. Sum first is 2, sum second is 3, means the difference is minus 1. So we have to return minus 1 because that is the minimum, right? So that's what they are telling, return the minimum difference possible between the sums of the two parts after the removal of n elements. So now just take a look at this example. Nums equals to 3 1 2, right? So first this is 3n, which means n equals to 1, okay. So we can remove one element. So if you remove 3, the first part is 1, second part is 2. So 1 minus 2 is minus 1. If you are removing 1, first part is 3, second part is 2. So 3 minus 2 is 1. So if you are removing 2, 3 minus 1 will be 2. So the minimum difference among all this is minus 1 1 2 equals to minus 1. Now let's take a look at the example. Now let's take this as an example, 7 9 5 8 1 3, okay. Now here n equals to 2, 3n equals to 6. So an array will be containing 3n of elements, right? Now for the what they have told, we have to remove n elements from the array, and the difference between the first part and second part we should calculate, right? So 7 plus, first initial, let's take 7 plus 9 minus 1 plus 3, 16 minus 4, which is 12, right? So if you remove this 7 9 5 8, that's also a possible. 7 plus 9 minus 5 plus 8, correct. So 7 plus 9 is same, 16, 5 plus 8 is 12, sorry 13, which is gives us 3. So now this is also a possible. I have removed this first two elements. So 5 8 1 3. So 5 plus 8 minus 1 plus 3, which is 13, minus 4, which is 9. So other possibilities as well. Now if we have calculated together, we have removed everything. First we removed this, second we removed this, and third we removed this too. So what if I remove 7 5 9 8 1 3, okay, 9 8 1 3. Then if you see, I can have instead of 7 I would have removed 9 7 5 8, sorry 7 5 1 3 could be also possible. If I would have removed 9 8, so 7 5 1 3 also possible. Or if I would have 7 9 and 5, so 7 8 1 3 also possible, 9 5 1 3 also possible. So the same way, if we would have chosen this side, let's assume we have chosen 7 9 from this. If you would have chosen 9 8 from this side, obviously this side will be 1 3 1, okay, because you have chosen 8, okay. But here if you have chosen 9 5, you have removed only one element, so we have possibility you can remove one as well. So in that case, what 7 5 1 3, what all other possibilities you have for this 3 instead of that 7 5 8 3 also would have possible, right? So 7 5 8 3 also possible, okay. But if you would have chosen 8, which means 9 8, if you would have chosen, already we have removed two elements. So here you don't have a choice, only 1 3 you have to take, because only 2 elements left. So whenever you are choosing 5, you have 3 elements. In that you can choose 8 3 instead of 1 3, right? So here also 9 5 1 3 also, sorry, 8 3 also possible. So among all this, if you have seen 9 8 7 5, all this 9, so 9 plus 8 is 9 plus 8 minus 1 plus 9 plus 8 is nothing but 17. 7 plus 5 is nothing but 12. So here the 7 plus 5, 12 minus 4, which gives us 8. 17 minus 4, which gives us 13. So 7 plus 8, which gives us 12 minus, so 15 minus 4 is 11. So here 9 plus 5 is 13, 14 minus 4 is 10. So here if you just take a look, 12 minus 11 is 1. Among all this, we have one which is very less, is 12 minus 11. So 9 plus 5 is 14 minus 8 plus 3 is 11, which is 3. So if you just take all the first 16, 13, 17, 12, 15, 14, 11, among all this, which is part of first part, which gives us the minimum differences, minimum among all the first parts, right? 14 12 14 12, so which gives us the minimum difference. First part should be minimum across whatever we have calculated, that should be, which is minimum, gives us the minimum difference. So if you calculate the second, if you just take the second part, 11 13 4, also we have 13, so this part should be the maximum, right, among all. So but when you are, if you see, if it is 13, when this should be maximum, okay. First part should be the minimum to the max, second part should be the maximum to get the minimum difference, maximum compared to whatever the values we are getting. But if the value 13 comes, which means the minimum is increasing, so we are choosing the second maximum, something like that. So generally what if you take any example, so 3 minus 1 will give us 2, 1 minus 3 will giving us minus 2. So first part should be minimum, second part should be maximum to get the minimum difference, right? So that is the concept we are going to use here, and we will be so this 5 and 8 can go to the first part as well as to the right part. So if you are taking 5, you should have the other arrays starting from A. For the right part, you can have it from 8 1 3. So for storing this, whether if you taken 5 into an account, what will be the result? If you take 8 into an account, what will be the result? That we will be storing in an array. So so for the left part, we will go traverse here. For the right part, we will traverse from left and right, so that we will be getting I hope we will get what is the minimum at till this point we want the minimum, right? Here we want the maximum, what we are getting with including 5813. Okay, here the maximum is 13 because we are not taking 5813 now. We have just taken 5 and 8. We have ignored 1 and 3. Okay, we have deleted 1 and 3. That's why. So now what? Let's take this as an example. So here now 7, for first what we would have done, 7 plus 9 we would have computed, 1 plus 3 would have computed. With that, what is the value? 7 plus 9 is 16. So 1 plus 3 is nothing but 4. Okay, because this is at the last, no? Right. So at this point we have removed 1, 5, 8. We just taken our own first and left part. So now if you are taken 5 into an account, we want a minimum value on the first part, right? So if you take 5 into an account, 7, 9, 5, which is maximum here 9. So what we will be doing, we will be putting all together. Here we'll have a total as a 16. Now 16 plus 5 we would have taken 21. 21 minus 9, because that we are going to pop it out, because that is the maximum, that contributes to the maximum sum. So what we will be getting, 21 minus 9 is 12, right? So update this 12 here. Okay, next now next, if you see, next we are going to add 8. 12 plus 8 is 20. Okay, but what is the now you would have put 8 into an account. What is the maximum element that contribute to this 8? So you will be minus 8. Again you will be getting 12. So still we know we have taken only 5. So at this point we would have taken 7, 9, 5, 8, and what is the minimum sum occur? At this point you would have taken 7, 9, 5. At this point you would have taken 7, 9, 5. So 7, 9 alone. So this is how we have, because this 5, if this 5 can go to for this part as well, to here. So if you have taken 5 here, okay, so if I am taking 5, 8 here, then what is left for me here? 1, 3 only left. So I have to choose that no matter what. So that will be the last I have added. So here I have taken 7, 9, 5 only. Okay, so if here what I have 1, 3, 8 I will have now, because here 7, 9, 5. So I will be having 1, 3, 8. Here we want a maximum, so that our difference will be minimum. Minimum diff will be getting by max minimum first part minus maximum second part. Okay, so to have it a minimum, what we have to have the maximum sum, we have to pop it out of minimum element. So I'm popping out 1. Okay, now if I'm popping out 1, what will be 3 plus 8 is 11. Okay, here we have only 7, 8, so we can contribute 5, 8 to this. Okay, now if you just take 1, 3, 5, 8, what is the, sorry, we would have already popped out 1, right? 3, 1, 3, 5, 8, here I will write, I have already popped out, now I have 5. So what is the minimum that I will pop it out? 3. So 5 plus 8 is 13. Okay, now these all the, if 5 plus 8 goes to right part, we will be getting maximum, but minimum goes too high. So we will be subtracting 16 minus 13, which is 3. 12 minus 11, which gives us 1. So 12 minus 4, which gives us 8. So we will be, for this 5, if it go to first part, if first we will be checking, I hope how we have computed all this. If without 5, 8, what will be the minimum sum, with 5 what will be the minimum sum, with 8 what will be the minimum sum. We are getting the same way we will be calculating the right part, so that we are figuring out what all could be the maximum possibility, right? So because only this 5 8 can go to the left part or right part. Other than that, for sure we will have one this 2. If you are removing this, we should have this calculated already. Okay, I hope this makes sense. So here, so among this whatever is minimum, we will be taking that into an account, right? So here here we need an array to if we are, for example, here we are just storing for example from once we have traversed the sum, we would have stored it in our total, right? So for that first at 0th index you are storing. Now we will be traversing from n till 2n, right? N, this is n 0 1 2, n till 2n means 4, which goes to 2 3. Okay, and store it into a array I minus n, because I will be 2 3, but we will be storing at 0 1, right? So this we will be storing 1 2, so 0 1 2. When you are traversing back, do we need an array? We just wanted to have them. We can just, whatever we are getting, we can just straight away subtract from the first part 1, right? Part 1 of I minus whatever the current part 2, because current part 2 will have the minimum sum already, because we are popping it out the minimum. Whenever you are, it's not mandatorily we have to store it into an array. We can ignore this, because we can have a variable that will have the current part, and you just subtract with the previous part 1 of whatever I minus n. Okay, I hope this makes sense. Maybe I can give you guys better example. Maybe I can just run through the code to make you guys understand better. Okay, now just take a look at the solution. Okay, before that I forgot. So here if you just see, we want only the maximum element to get pop out, right? Here we want only minimum elements to get. Why can't we use heap here to get elements to be popped out at order of log n, right? So we will be going have it as a max heap. This is going to be a min heap to pop out the elements. Yeah, now this is just exact same thing that we have used to solve our problem as well. Now what we are going to do initially, we are going to store it in an array, right? Let's have it as a part 1. Part 1 we need to store just n elements, so n plus 1, because this will be the total, and the remaining n, so n plus 1 elements we want. So that's what 0 1 2, n is equals to 2. We will be having index of 3. So what we will be for initially will be having a total sum of, will be having nums, right? Nums till n, I have the sum which gives the total 16. Let's store the first part of the element in pq left, which will have, we have to store it as a max heap, right? So generally heap itself min heap. So if you want to max heap, you have to do store it in a negative value, so that whenever it is popping out in negative, the maximum element will be the minimum, right? So that's why we are doing negative here. For x in nums till, we will be storing first element, first n elements we have stored, which means priority queue will have 7, 8, right? Okay. Next, part 1, what we will be storing, part 1 of 0 will have 16, which is total. Now we would have now the priority queue has left, the total is nothing but 16, right? So that we would have stored it in the part 1. So which means at till this point we have stored 7, 9. Okay, next we'll be taking 5 into an account. What is the minimum that at that particular point, what all the two elements that contributes to the minimum value, that we will be storing in the rest. The same way we'll be storing for the right part as well. So now for that, for till from where we have already taken from here, we have to go till 2n, right? So let's write that example here: 7, 9, 5, 8, 1, 3. Now we will be traversing till here, and we will be keep on taking whatever the minimum value, and we will be adding their sum into that particular point. Okay, so now just take a look. For what we will be doing, we will be adding the nums of I. Right now we will be putting into the priority queue heap push of my pq left comma nums of I minus nums of I, because it's a max heap, to get the maximum element to be popped out. So now what we will be putting, we will be putting 5. So now if you put 5, what is the maximum element to be popped out, right? So what we will be doing for that, we will be popping out heap pop of pq left. So maximum element will be pop out, that you have to just subtract. Already it is sub minus, so you can just do plus or equals to whatever the popping out. So now popped out element will be 9. So 7, already the total would have got updated to 7 plus 5 plus 9 is 21, minus 9 again goes to 12. Then now you would have updated to 12 here. It's the same when 8 comes. So for next I equals to, so total 12 plus 8 will be 20. When you add 8 into here, next pop pq left also will pop out 8. So again you will be minusing 20 minus 8 will give us same 12 as a total. So at this point only our minimum value is 12. Okay, now next we have calculated the part 1 now. So now we will be going for the part 2. Part 2, what we will have to calculate, sorry, in this we have to store it in a part 1, right? So part 1 of, since we have taken 0, 1, 2, right, which I is range from n, which means 2, n is nothing but 2, right? Yeah, 2 to 2, 3, 2 to 4 it will range. So what we have to do, we have to subtract I minus n plus 1. Why we are doing plus 1? Because we are storing it from 1 index. So I minus 1 is, which means 2 minus 2 will give us 0, 0 plus 1. So this 0th will have the total of the first left part. Then for storing this, we are storing at 1, storing at 2. So part of I minus n plus 1 will give, we are storing the total. Okay, so this part is done. Now we are going for the part 2. Part 2 will be calculating the sum of nums of last, we have to store it. What is that? 2n, right? Yeah, from 2n you have to store everything. Okay, so the same pq, right, what we will be storing nums 2 from 2n till everything. So we will be doing heapify of pq. So heapify of pq, right here, this is our max if we want. So I mean heap, so we want min element to be popped out, we have to store the maximum, right? So this is min heap. So once we do heapify, it will be, so answer equals to, initially now we are going to store the answer. So now if you take this example, at this point we have initially part 2 will have this, so which means the left part holds this, whatever the minimum will be storing at the last index. So this has 7958, right? So this would have stored whatever the minimum, or if you have considered this as a left and this as a right, and by deleting two elements, okay, this will store by after deleting two elements, and this 58 goes to the first part, which means 12. So how will you calculate that? We will be getting it from the part 1 of, now let's take n, sorry 2n, so part 1 of n, because 2 only has that value, right? Okay, 0, so n minus part 2, so which is 12 minus 4, answer currently will be 8, right? Now we have to see, we have to consider, now what if 8 comes to the right, 5 comes to the right, but among this whatever the minimum difference we will be taking into an account. So for I, again in range 2n we have taken already, so 2n minus 1, 12n minus 1, which means till the n it should go, n is 2, right? So that we are putting, because we are going in a reverse, so we are putting n minus 1. So now the same you just do total, so I will be having it in the part 2 of will have part 2 plus or equals to nums of I. So now we are putting the same heap push of priority queue, right? You can put straight away nums of I, because it's a min heap, so whatever popping out will be the minimum already. So now we'll have this, okay, now it has 1 3. Now we have to pop out the minimum element, heap pop of PQ, right, will be popping out the minimum element, that you have to do total minus part 2 minus or equals to, right? So we will be doing part 2 minus or equals to PQ dot, right? So now answer will be answer minimum of answer, comma part 1 sum first minus sum minus, right? That's what we are going to do here, I minus. So let's take now here let's assume I equals to 3. So here I is present 2 3, right? Because this we have already calculated. Now I comes 3. If I equals to 3, if I is at 3, we have to calculate if I is 3, we should know till where left part will be having the minimum difference will be 2, right? So how we will be getting the 2? So I minus n, so which means 3, if 8 goes to the left part, we should have in the right part 795. Among that what we have deleted is 9. So that we would have stored at the index, this is at index 1, right? Yeah, 795 is at index 1. So if you just see I have 795 is at index 1. To get that index we have to minus 2, which means n, okay, yeah. So I minus n minus part 2. Why we are straight away doing part 2 is because instead of here we have stored it in an array, right? But the part 2 generally has the minimum, what is the current minimum, so it's not like we have to store separately into an array and we have to fetch it via index. Okay, part 2 already has the minimum, so we can straight away, instead of using an array, we can avoid order of n. So yeah, that's it. Then we will be returning answer. So now what it would have put 8 into heap push, part 2 would have calculated to 12, and we would have popped out the minimum from this. So 12 minus 1 will be 11. So here 12 minus 11, answer would have got updated to 1. So here the answer got updated to 1. So next, when 5 comes, when I goes to 2, right? Now I would have got updated to 2. So part 2 will be plus 11 plus 5 will be 16, right? So part 2 would have updated to 16. So 16, and if you see now, that's we would have put 5 into account. So now if you are popping out 3, 16 minus 3 will be 13. So part 2 is 13. So 12. So now if you go here, part 2 is 13. This is, so now since we have to subtract this, right? Now 5, 8 gone to the right part. So they have removed 1 and 8, 5, sorry, they have removed 1 and 3. They have taken 5, 8 into an account, so which contributes to this 13. So what is left to the left part? 7, 9, which is 16. So now 2, what is the I? So 2 minus 2 is 0, okay, which is 16. 16 minus 13 will gives us 3, but answer is already minimum we have 1, so we won't get updated. So among this, so the basic simple ideology here is, if this is 5, 8, okay, so initially you have assuming we are removing 5, 8, and you would have stored 7, 9 separately and 1, 3 separately, which is at the part 0. Initial part 2 will have this, right? So now if you are taking 5 to the left, 8 to the right, left, what will be our minimum sum? We have calculated the same. When we are giving 8 to the right, what is the sum at till this point? So that we are subtracting, and among all this, whatever the minimum comes, that we are picking up and we are returning, okay? So these are the different cases, and by this we have calculated all this possibilities. So the time complexity will be to the max. If you see, we are traversing to the length of the array, and we are just traversing the 1n 2 times, so which straight away it won't have any difference. So order of n, and every time you are pushing and popping out from the element, right? So that will do a log n operation, log n plus log n, which in turn contributes to the log n only, okay? So n log n. So space complexity is order of n, for which we are storing the pq left and pq right. So yeah, this is the time and space complexity. Now let's look into this is the same solution I have just implemented in LeetCode, and yeah, now just take a look at that solution. That I have solved will be having the part 1, which will store the first n nums. In this case we would have stored 7, 9, and we'll have a max heap. So when we will be traversing, we have 3 n elements. We need first left part n and second part another n. So in between n, it can go to the left as well as right. So initially, to have the minimum difference, we need as we discussed, we need minus, first part should be minimum, second part should be maximum. So we have a max heap, so whatever the maximum element comes, we are popping it out, right? So that's what we are doing here. The same for the next, we are storing for the last n elements for the first. So then we are subtracting it from the part 1 minus part 2, part 1 of n minus m, and we are keep on if 8 goes into second part, will be what will be the maximum minimum value we would have got for at this particular index. Like that, we are just subtracting with part 1 and part 2, and we are obtaining the answer. So the same whatever I explained in the pseudocode, the same we would have solved here. I hope this makes sense to you guys how this all works. And the time complexity, space complexity is time complexity will be n into log n, because to pop and push, and space complexity to store it in a heap will be storing in order of n. I hope this makes sense. Now if you run, yeah, it will get submitted. I hope you guys would have understood the solution. If you have any questions or any further clarification, something I could have explained better, please do leave a feedback in the comment section. I'm happy to hear your feedbacks. And yeah, hope you guys would have understood. Yep, thanks for watching. If you do like my video, please like, share and subscribe and share it to your friends, so that will make me motivated to do more videos daily. Yeah, once again, thanks for watching.